Hi, you guys. This is Miss Johnson. We're talking about molarity, and this is when we have to dissolve something solid into usually water. It's under Unit 6, which is chemical reactions. So we did this when we took the sodium hydroxide and we made it up in the lab. Okay? Molarity is how concentrated something is. We talked about coffee, how you can make it, stronger by using less water. And Kool-Aid, you can make it a darker color by having less water. So when do we use this formula? Well, in my class, when you see grams, like how many grams do you need to add to this on a worksheet, it's going to be a molarity formula. But common sense should tell you anytime you have to take something solid like salt and dissolve it into water, that is going to be molarity. So this is our first problem. What's the concentration of a solution that has 24 grams of sodium sulfate dissolved in 750 milliliters of water? The first thing we need to do is convert milliliters into liters because our molarity formula calls for liters. The second thing that we need to do is that we need to find the formula. Sodium has a +1 charge. Sulfate has a -2 charge. When I do the crisscross, I get the formula Na2SO4. So that's going to be my formula for sodium sulfate. And I know it's been a while since we talked about formulas, but I told you you were going to use them forever. Ha ha ha. It's not funny, but it's important. Okay. After you find the formula, then you can find the formula weight, right? And this is where we're going to take all of the atoms in the formula. We're going to look up their mass on the periodic table, and we're going to multiply how many atoms we have by their atomic mass. So, for example, in our case of sodium sulfate, we've got 2 sodiums. Oh, there it goes. We've got 2 sodiums, 1 sulfur, and 4 oxygens. So when I add all those atoms together, they have a formula weight of 142.041 grams. The last thing I have to do is go ahead and convert my grams into moles. Actually, it's not the last thing. I've got to convert my grams into moles so that I can solve for molarity at the very, very end. So now all I'm going to have to do is plug in that number of moles that I just found into my molarity problem, and I get 0.225 molar. Yikes. Okay, how many grams of potassium permanganate would need to be added to make 2.5 liters of a 0.025 molar solution? So this time we want to figure out how many grams. Well, I know I can convert moles into grams, and moles is the thing I'm going to solve for, and this is the formula from class that we used. I need to also find the formula. Potassium is K, and it has a +1 charge. Permanganate is MnO4 and has a -1 charge. So that's my formula. And I'm going to need to convert grams into moles, moles into grams. So after I solved for moles, I had 0.0625 moles of that stuff. And I just need to convert it into grams. I'm going to use the formula weight, just like we always have. So I looked up the mass of potassium, the mass of manganese, and then the mass of oxygen. And I had 4 of them. So that's how I came up with that. Okay, how many grams of lithium hydroxide must be dissolved in 575 milliliters of water to achieve a molarity of 0.5 molar? There's a lot going on in this slide, and I'm going really fast. So I'm finding the formula first, lithium hydroxide. I'm finding the formula weight next, and then I'm plugging in to solve for the number of moles, because I know that I can convert moles to grams in the very end. Like I said, there's a lot going on this slide. So the last thing I do after I solved for the number of moles is I just have to convert into grams using the formula weight. So 0.2875 moles of lithium hydroxide. The formula weight of lithium hydroxide is 23.948. you multiply them together. Wow, great job. It was way too fast. I'm sorry, you guys, but try to be happy. Yay.